Assalamualaikum and very good day to our lecturer, Dr. Ahmad Fatih bin Muhammad Noor. We from group 5. My group member is Faiz Ashraf, Mavison, Nur Aina Amira, Nur Najiha Ismi, Nur Suaida binti Ramlan. For our title project is voltage seg in the photovoltaic PV system and mitigation technique using the desktop. For the project background is the electrical network or grids ability to supply clean and stable power is measured by power quality. The power voltaic technology is an interesting technique of the energy generation that satisfies the criteria of clean energy and long-term sustainability. The purpose of this project is to find a power quality compensating device which will rectify the power quality problems such as a voltage sag which occurs in a high voltage power transmission line. Okay, for the problem statement is power quality is defined as any problem with voltage, current or frequency division that causes failure or the loss of functioning of customer equipment. Power quality problem which voltage sag, swell, short, flickers, interruption and harmonics. The modeling of the Stockholm will be chosen as the combination method to handle the voltage sag in the PV system, and the performance must be optimized in accordance with the installed equipment. Okay, for the objective is to observe the effect on the characteristic of voltage sag on the PV system. Second one is to investigate the mitigation technique that is suitable for the voltage sag in the PV system. Third one is to suggest the stability technique used for the mitigation process. For the scope is this project involves simulation MATLAB. By using the MATLAB, we produce a model and arithmetic schematic. We simulate the power quality problem caused by the voltage sag. Second one is the simulation focus on the photovoltaic solar panel system, and the Stockholm plays a vital role as compensating the method. Third one, all data for this project is collected and analyzed through MATLAB software. Number 4 is investigate the voltage sag with the Stockholm and voltage sag without the Stockholm.
Assalamualaikum and a very good day. My name is Aina Amira binti Cikgu Abu Bakar, matric number CE180166. I will present the literature review of this project. So the voltage sag is commonly power issues that always occur in PV system. It is also known as voltage dip, a type of disturbance in which the RMS value of the line voltage drops for a period ranging from 1/2 cycle to 500 milliseconds. It also may lead to grid stability problems. The PV system needs to disconnect the grid quickly to avoid islanding issues when the voltage sag occurs. It can cause a huge loss of the PV generated power that may lead to the problems in the operation and stability grid. The figure shows the waveform of the voltage sag. Second is the harmonic distortion. It is one of the major effects that are considered in PV system operations. The presence of harmonics means that the current and the voltage are distorted and deviate from the sinusoidal waveform. The transformation from DC to AC through inverters where it infuses the voltage and current harmonic into system resulting to the power harmonic in the system. So it can generate eddy current in wires which can cause skin effect. The figure shows the example of harmonic waveform. Next is voltage swell. It is initially known as surges, were similar with the voltage sag except that the voltage surpass user-defined high limit. It is increased between 1.1 pu and 1.8 pu in RMS voltage or current at power frequency duration from 0.5 to 1 minute. It can be affected by the de-energization of a very large load. The figure shows the voltage swell waveform. Next, the power quality mitigation technique using the DS STATCOM. Distribution static compensator, or also known as the STATCOM, is the power device which is implemented in shunt configuration where it can be dynamically help to improve power quality problems. It can be operated in two modes, which are voltage mode and current mode. The DS STATCOM is one of the power device which is connected to shunt and its component are VSI, DC link, device where it is required for energy storage, a filter in output stage, and with a coupling transformer shown in the figure. So the summary of the previous research are first, as the STATCOM used to eliminate the voltage sag in the PV panels, and at the same time it can share some of the real power demand. Second is the STATCOM behaves as a good solution to mitigate the voltage sag in distribution grid. That is, the waveform of the voltage becomes sinusoidal after it connected with the STATCOM, and the STATCOM efficiency is depends on its effectiveness in extracting the reference current signals. The STATCOM improves the power quality problems and reactive power compensation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Najwa binti Abdul Latif and my matric number is CE180177. Okay, so we go to the methodology. Firstly, we go to the flowchart of the project, which is we start construct the PV system circuit with distribution section in the MATLAB, and then setting all the suitable parameters of the components, and then run the simulation. After that, we need to identify is it the simulation have the voltage set. If it not have a voltage set, then this output graph will be analyzed. If the voltage set is occurred, then we need to connect the PV system with this STATCOM device. After that, run the simulation again and then check and identify is it the mitigation is succeed or not. If the mitigation is succeed, then we can analyze the output graph. Okay, next we can go through to the photovoltaic PV system. PV system have a three type, which is a standalone system, hybrid system, and grid connected system. In this project, we use a grid connected system. Okay, as we can see here in the figure is a block diagram of PV system. In this PV system, we have inverter, which is this inverter helps to convert direct current electricity from the sun to the alternating current AC. This inverter is fully automatic, which is this inverter will synchronize with the grid. For this inverter is no operator input required under normal operating condition, and this PV system depending on the grid connection requirement. Is it run in a single phase or three phase system, and this export into grid when the generation exceed demand, and this PV system offer great potential in Malaysia. Okay, next we can go to the modeling this STATCOM. This figure shows a circuit of this STATCOM. This STATCOM have a VSC, which is voltage source converter. It also have a DC link capacitance, coupling of inductance, and PWM pulse width modulation signal. This VSC is convert DC across the capacitor into a set of SC output voltages. It has active and reactive power exchange between this STATCOM, and using an indirect control converter, this device is being used to provide continuous voltage regulation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Pak Yasraf. I will explain the modeling for the circuit. For the first, grid connected modeling. A grid connected distribution system is modeled to achieve a reliable working for the PV array system. The grid voltage has been provided with rated active power. The active power injection was reduced until the minimal optimum active power value was reached. The distribution system consists of two different loads connected to three-phase, three-winding step-down transformer, and the transformer is to step down the 230 kV to 11 kV without changing of its frequency and directly connected to the three-phase RLC, resistance, inductance, capacitance, loads. So for the next, grid connected PV array without distacom modeling. So PV cells are grouped in larger units called PV module, which are further interconnected in series parallel configuration to form PV arrays of PV generator. It consists of an arrangement of several components, including solar panel to absorb and convert sunlight into electricity, a solar inverter to change the electrical current from DC to AC, as well as mounting, cabling, and other electrical accessories to set up a working system. A detail of PV array model is 100 kilowatt array connected to a 200 kilovolt grid via DC AC boost converter and three-phase three-level voltage source converter (VSC). And lastly, for the modeling grid connected PV array with distacom modeling, distacom is used to coordinate power, stabilize voltage, and improve power quality. By applying distacom circuit to grid connected PV array system is helped to increase the stability margin of the system and improve the voltage regulation to control the receiving end voltage or the voltage at load. This TECOM is connected with secondary winding and primary winding is connected to 200 kV of the three-phase, three-winding step-down transformer. That's all for me. Thank you.
Hello, my name is Melvison. I'm going to present the result discussion for this work. So in this work, the detailed simulation are performed on the Statcom equivalent circuit connected to a distribution system which was modeled using MATLAB Simulink to observe the behavior of the distribution with the PV array system. So for the result, there are three graphs which are simulation of grid connected circuit modeling, simulation of grid-connected PV arrays with the StatCom circuit modeling, and simulation of grid-connected PV arrays with the StatCom circuit modeling. This is the first result, which is grid-connected system graph. The output of a grid-connected system for three-phase voltage shows that the voltage graph produces a sinusoidal wave and no power quality problem occurs. This is because no PV arrays are connected in the system to interfere with the voltage. Then, to achieve the objective of this project that focuses on the PV system, the grid will be connected to a PV array system to demonstrate the effect of the PV array system. So this is the voltage graph of grid-connected PV arrays without the StatCom. The result simulation of grid-connected PV arrays shows that there is a power quality problem, which is voltage sag occurs in the period of 0.224 to 0.226 second of the RMS voltage. The voltage sag happen in grid-connected with array system is because of rapid change of load such as motor startup or a short circuit. In general, the closer to the point of failure, the greater the voltage sag, and the more serious the hazard would be generated for the sensitive electric devices. Then, to mitigate the voltage sag is by connecting the DStatCom to the system to improve the power quality. So this is the connected DStatCom. This is the voltage graph of grid connected PV arrays with the StatCom. The graph shows that the voltage produces the same sinusoidal waveform as before connected with the PV array. The voltage sag is mitigated completely on the RMS voltage. The StatCom behaves as a good solution to mitigate the voltage sag in the distribution grid. That's all from me. Thank you.
For conclusion, problems affecting power quality should be dealt with effectively in order to maintain power quality. The power quality problems of the solar power distributed by applying a compensating device like the STATCOM, voltage issue may be recognized and avoided. The characteristic of the voltage will be found based on the simulation and result which we obtain in a graph from the MATLAB software. The recommendation of the future work, it will develop digital controllers to regulate the power electron switch in the device and research the device function in reducing other voltage problem in the power system. That's all.